So today we're going to be reviewing a couple of topics. We are going to look at derivatives and partial derivatives of log utility. Okay, so as we have seen, or as we probably know, the derivative of the log takes a very simple form. The derivative of the log, so taking the first example, we have a function u natural log of x1. The derivative of the utility function with respect to x1, the derivative of this is simply 1 over x1, by definition. Okay, so given that we have this, now we're ready to tackle the harder problem of understanding what is the utility or the derivative of a function that has two terms. So notice that here the u has a term x1 and a term x2. And so how do we take the derivative of this thing? Well, here we need to use the idea of partial derivative. Partial derivative. The idea of a partial derivative is quite simple. Here, although we have two terms, we want to take the derivative only of one of the two terms. So we can have the derivative of the utility function with respect to x1, or the derivative of the utility function with respect to x2. So in other words, when we have this kind of function, we can get two possible derivatives. Option A is to take the derivative of the utility function with respect to x1. Option B is to take the derivative of the utility function with respect to x2. And what this means is essentially saying, I'm going to look at how the utility function changes with respect to x1, holding x2 constant. And here, I'm going to be looking at how the utility function changes when I change x2 and I hold x1 constant. Okay, so the two are called partial derivatives because of that. Now, when you do that, then what? Then we're going to have to use we're going to have to take the derivative of the derivative of the utility with respect to x1, holding x2 constant. That means that we're going to consider x2 as if it were a fixed number. Okay? So then we're going to use, to get this derivative, we're going to have to use the chain rule. And the chain rule is going to be as follows, right? So first, you have the log of something, the outside function, which in this case is x1 times x2. Sorry, this is a times. x1 times x2. And the second one is going to be then the derivative of the inside function, which is going to be x1 times x2, and take the derivative of that with respect to x1. Okay, so first, what is the derivative of the outside function? The outside function is the log of x1 times x2, so the derivative of that, based on this, is x1 times x2. So this is the derivative of the outside function, and then the inside function, I have x1 times x2. When I take the derivative of x1 times x2, I'm treating x2 as if it were a number. And therefore, you know that by the constant rule, we write down that number, which is x2, and we multiply that by the derivative of x1, which is just 1. So that gives us x2 times 1 divided by x1 times x2. x2 cancels out. And what we get is that the derivative of u with respect to x1 is simply 1 over x1. We do the same for the derivative of utility with respect to x2. Again, now we're going to hold x1 as constant and just focus on x2. And so that's going to give us 1 over x1 times x2, which is the derivative of the outside function, which is the log. And then multiply that multiply that by the derivative of the inside function, x1 times x2, holding x1 constant. We write it down there. The derivative of x2 is just 1, and so we get 1 over x. Thanks.